Hello, welcome to a demonstration on how to generate regression statistics using Excel. Okay, yes, Excel can actually do this. Many people who are performing scientific research, they always use other more sophisticated statistical tools like SPSS, SAS, etc., etc. But Excel can also do the same, but it's always important to remember that Excel is not yet accepted as the primary generator of any scientific research. So whenever you're actually performing a really detailed scientific research for publication, you need to be aware that you have to use the recognized statistical tools like SPSS, etc., etc. So it's very important to remember that. But however, Excel really brings down to earth some of these complex calculations in regression analysis that can really be very helpful to develop some deep understanding of what is actually happening in the black box, for lack of a better term. All right, so we'll be providing a demonstration of that, and we'll be able to explain the regression statistics that will be generated using this particular method. So again, buckle up and be ready to learn some new concepts that can really make a huge difference in your professional life as you pursue some of these very important analysis in your career, or you could be going to college, or you could be doing this just for fun. Whichever perspective you're looking at this from, I'm very hopeful that you're going to learn a lot from this demonstration. Okay, so how do we activate the regression function in Excel? Right, what you have to do is you go to a data set, or rather the data tab enables you to see if you have got the data analysis function activated. But now by default it does not come up, and so you actually have to set it up as an add-in. So in my case it's already showing up because I've already activated it. So in order for you to activate it, you can go ahead and click on File, and while you're there you'll be able to see Options. Right, it's actually towards the bottom. Click on that. It opens up a dialog box for you, and then under the Excel options you'll see this add-ins. Right, so you click on that, and then there will be a change that will happen to the dialog box in the middle of the screen, where Manage Excel Add-ins will actually show up. And all I have to do is just click on Go, and then it opens up a small dialog box here, and that's where you'll be able to see Analysis Tool Pack. So all I have to do is just put a check mark on that. You must have a check mark. I had a check mark on it, that's why data analysis was actually showing there. Once you've done that, you can go ahead and say, okay. Then your data analysis will actually show up there. So all I have to do then, you just click on data analysis, and it opens up a dialog box which will provide a whole range of analysis tools that's actually available, or statistical tools that Excel can actually perform. Now in this case, we're actually looking for regression, right? So we can scroll down if we can't see it. Everything's sorted out in alphabetical order. So you'll see this regression right there. So it's either you just click on it and say click OK, or you can double click on it. Whichever way you do it, it still takes you to the same place. Then the working dialog box opens up. Then it's now saying, what is your input Y? Input Y would be our dependent variable, that which we want to predict. So in this case, it's actually the sales volume. So we select the sales volume. Then input X is our independent variable, which is the predictor. So it's the number of commercials. So by now you've already figured that this is a very small data set that we're actually using, and it's actually for an electronics company where they run some commercials in order to drive their sales. So they want to figure out if the number of sales actually influence the number of commercials, where they actually influence the sales volumes, right? So again, that's a very basic way of performing a regression analysis. So all we're trying to do here is try to generate some regression statistics and we're going to interpret them to see if that is in fact true or if it's not true at all. Okay, so back to our dialog box. So once I've selected the input X, which is our independent variable, we can also select, put a check mark on labels, showing that the first row is actually a label, right? Those are labels. Then beyond that, we can then figure out where do we want our results to be placed on this particular screen. Do you want them on the same screen or do you want them on a separate page? Do you want them in a separate file, right? So Excel is actually able to do that. But in this case, I want the output range to be on the same screen, right? I'm doing this for a purpose. Just want to make sure that I can examine the data on the same page where the results are actually going to be, right? But there's no harm in actually putting this on a separate page. If you wanted that, then that is going to be much cleaner for you, right? But for the purpose of this particular demonstration, we'll put this on the same page. So make sure that you select output range and place your pointer inside this box and click in there. Then that way, Excel knows exactly where you are. Then all I can say here is click on E2. So in other words, the first results of from this regression statistics output must begin in E2, going across or downwards, right? But the first output should be in there. So once we've done that, we should be good, and then we go ahead and say, okay. And before you know it, we've actually generated the summary output, right? It's kind of magical when you're actually looking at it that way. And then we want to clean up a little bit. So I select using the columns here so that I can do what I call a right fit. So when I double click between the columns there, I'm actually able to expand the columns large enough so that all the information in those columns is actually readable, right? One more cleanup I need to do here. You'll see that the lower 95 and upper 95%, they're actually repeated, right? For whatever reason, Excel repeats those last four columns. So it's kind of, the last two are actually redundant. So I can delete those, right? Just to clean up so that I can have a much better visual experience of the results here. Okay, now that we are done with our cleanup, we can now begin to interpret the simple regression statistics that we've just generated. Now, you will notice that for those of you who are familiar with SPSS, the order of our presentation is about the same, right? It begins with the summary of regression statistics and then moves on to analysis of variance, which we'll call ANOVA, and then concludes by looking at the coefficients and the p-value down there. So the order is always the same, but many argue that ANOVA should be at the top, right, followed by regression statistics. The reason being that the foundational basis for all these calculations actually come from ANOVA. For whatever reason, ANOVA is always placed second, yet in fact, that's the starting point, right? When we are actually calculating all these numbers, all these statistics, we actually begin with ANOVA. How truthful is that? For example, when you look at the R square that you see right there, it says as a result of equal sign, the sum of squares for the regression divided by the sum of squares total. You see that when I do that, this number is exactly the same as that R square, right? And then of course there's adjusted R square where we take into consideration the sample size. So we adjust the R square because of that. So it's actually, that's the argument that many tend to say, well, ANOVA should come first because it's foundational to everything else that we're actually doing here. Anyway, that's a discussion for another day. So moving on, let's kind of quickly interpret what these regression statistics actually mean. So about 93% here is explaining the strength. So the strength of the relationship between number of commercials and sales volume, it's at about 93%, which means if it was 1, it was going to be perfect. It was the strongest relationship you can find, and chances are one may say there won't be any other variable that have actually been overlooked. But here it's actually saying, well, the strength is very strong at 93%, right? That's all it's telling us, just the strength of the relationship. Whereas the R square is telling us the variation, how much of the variation of the sales volume is being explained by the number of commercials. So commercials can explain up to about 87% of the variation in sales volume, which means about 13% those variables are known. So there are other variables out there that we would actually include in this particular model to strengthen our prediction, right? But still 87% is actually strong enough. Adjusted R square is still R square, but the only difference is that it's actually adjusted for the sample size. And in some cases, some of these models can actually also adjust for the number of variables as well. So it's a more conservative R square that is widely recommended to be used, because you always want to be more conservative when you're actually making predictions. Do not to overestimate anything. And standard error is simply telling us the data dispersion, how spread out the data is, right? And usually it's not as meaningful unless if you're actually comparing multiple variables. Okay, but at least it gives you an idea that it's just measuring the data dispersion, how spread out the data is. And observation, simply the sample size. And then we move on to the ANOVA, which is the foundational statistics that we actually use to calculate the rest of the stuff. But however, it does also include a very important statistic here, which is significance F, which is actually the equivalent of our p-value. You can see it's exactly the same. In a simple regression analysis, you always find that these two numbers will be the same. But if we have multiple independent variables, then you'll find that the number that you see here will be different, because here you will be having a breakdown of multiple variables, right? So in a multiple regression analysis, the numbers will be a little bit different in that particular regard. But however, when you look at significance F here, what does it actually tell us? Now, we've tried to figure out whether the relationship is statistically significant by actually looking at this number, or the p-value for that matter, okay? Now, in this particular case, we want to see if this number is lower than 0.05, okay? So 0.05 is our benchmark. So if this number is lower than 0.05, then we know the relationship is statistically significant. But it's not obvious, isn't it? Right? Because it would appear that this number here looks like 9.38553. But wait a minute, there's an E. How can we have a character in a number? It means that it's a scientific notation. This number is actually a scientific notation, which means that this number actually is up to 5 decimal places, right? So this number is actually up to 5 decimal places, which means that the 9 only begins from position 5. So what does this mean? We can actually recalculate this number by saying 0 point, then we go 1, 2, 3, 4, then 9, 3, 8, 5, 5, 3. Then we press enter. You can see that we've actually been able to reproduce that number. Okay, So this number, in fact, is actually, you can see when you can actually look at towards the top there, and the formula bar, you can see that it's actually, this number is smaller than 0.05. So the relationship is statistically significant. Always pay attention to a character that's actually included. It simply signifies the number of decimal places. Okay, so in this particular case, now we know that the strength of the relationship is 93%, and number of commercials can explain up to 87%, and on the conservative side, it explains about 85% of the variation in the sales volume, and we've actually been able to evaluate that the relationship is in fact statistically significant. All right, and again, we can see after explaining this here, we don't even have to explain the p-value down here because we only have one independent variable, which is the number of commercials. But however, we need to explain the coefficient. All right, okay, so the coefficient here is actually telling us that for every a change in 1 unit of the number of commercials, every additional commercial that we actually run, right, our sales will actually increase by 4.95 for every additional commercial. Okay, this is actually our slope. That 4.95 is actually our slope, and the intercept is actually our constant. So actually using this, we can actually derive the regression equation from this, where we say y is equal to 4.95, which is actually our slope. So for every change, this is actually our slope. It says that for every change in our in our independent variable, right, the slope will give us about 4.95. Okay, so here now we can actually try to derive the regression equation. So which means y, right, which is actually our dependent variable, which is the sales volume, is equal to slope, okay, multiplied by the number of commercials plus the constant. The constant. So because of that, we are actually able to say, okay, so we can say equal sign, we can say y is equal to, in this case, we know what the slope is, 4.95 multiplied by the commercials, the number of commercials, plus the constant, which is 36.15. Okay, I can move this down a little bit so that we can see the numbers, right? Okay, so it looks more like that. Okay, it's 36.15. So therefore, okay, let's go back to that. So therefore, let's say, for example, in this particular case, when we look at the number of commercials, we can see that the number of commercials, they range from 1 up to 5, right? So what about if this organization was going to run 8 commercials or 7 commercials, something higher than 5? Can we predict the sales volume using this linear regression equation? Yes, we can, right? So we can say equal sign 4.95 multiplied by the number of commercials, let's say 7. What about if we had 7 commercials plus the constant? And it's actually telling us that if we're going to run 7 commercials, our sales are likely to be 70.8. Does that make sense when you actually look at the data set? Yes, it will be higher than any of the values we have here because it will be the highest number of commercials considered so far. So what is the significance of this? It means that once we have actually generated these regression statistics, we are also able to derive the regression equation where we are actually able to predict our dependent variable by manipulating changes in the independent variable here. So we can actually calculate sales volume for any of the number of commercials that we wish, right, to have. So again, very, very powerful interpretation of regression statistics that can really give you a very useful foundation to have a much solid understanding of regression analysis interpretation. But anyway, just one more thing here. Okay, remember we're actually able to use our coefficient, and we're actually saying that for every change in the number of commercials, right, every one additional unit will actually increase the sales by 4.95. This is actually our slope, but it can be as low as 3.36 and can be as high as 6.54. So it's important to understand that this coefficient, right, is actually the average of these two values, right? So this is the average, but it can be as low as 3.36 and it can be as high as 6.53. But is that really true? So if we find the average, so let's calculate the average of the lower and the upper, you will see that it gives us the 4.95. Right, so our numbers actually check out, and we've pretty much explained everything that we needed to explain here. We've been able to understand regression statistics, what they're actually telling us, the strength of the relationship, how much of the variation is being explained by the independent variable. We've actually been able to see that, and of course we did recommend that you use 85%, which is the more conservative one. And then of course we looked at the ANOVA analysis of variance here, and the significance of analysis of variance, and the most important number that was coming out of here was that significance F, which is the same as the p-value, because in this particular case it's a simple regression. Okay, so therefore the numbers are going to be exactly the same. But if it's in a multiple regression scenario, because we'll be having a breakdown of multiple independent variables, this number then changes, because it will be a collective statistical significance of all the variables I will be having down here. So in addition to that, we did quickly walk through the coefficient, explained what it actually means, and also at the same time, we're actually able to derive the regression linear equation so that you can actually see how we can actually use that to predict the dependent variable. And again, also bearing in mind that the coefficient you get here, it's actually the average of the lower and the upper. It's always very important to understand that. Of course, why would that be any different? Because the standard error, there's a data dispersion, right? Right, the data is actually spread out. So the 4.95, it's not fixed in stone, for lack of a better term. Otherwise, that's all I have for you. I hope you found this video insightful, and hopefully it solidified your understanding of simple regression analysis. Again, continue to visit my channel and you'll be able to see that I'll provide some additional examples of multiple regression where we also go through some detailed explanation of what each one actually mean, and hopefully this video will actually serve as a useful foundation to build on as you continue to visit my channel and learn more about some additional analysis that I'm going to demonstrate. Otherwise, that's all I have for you. Thanks so much for watching. If you like the video, please like the video, share the video, and subscribe to the channel. And again, do not forget to provide some comments so that I can continue to to learn from your feedback. It's very, very important so that we can all continue to grow in this particular area, which is very, very important, that can really make a huge difference in our lives. Thank you so much for watching, and bye for now.